So now we've gone through and we've determined how we're going to set up our breeding program. Now we can get down to the nitty-gritty of this and figure out what type of breeding system we're going to use to accomplish our goals. So the first type of system we're going to talk about is grading up. Typically with this kind of a system, you're going to take purebred sires and breed them commercial females. The replacement females are kept back and bred back to the purebred sire. The aim of this type of a system is to produce progeny resembling the purebred sire. Typically with this system, you're going to see noticeable improvement by around about the 4th generation. Next type of system you may be considering is crossbreeding. So with this type of system, you're mating animals of different breeds. The aim of this type of system is to take advantage of both hybrid vigor and breeding value. So hybrid vigor, or heterosis, is the crossbred offspring exceeds the average of the two parental breeds. So basically, and like I said, this is where if you're taking a look at your parents and you've got one breed that is really great at maternal traits and you got another breed that maybe is really great at carcass traits, and so you decide that you want to crossbreed these two so that you have animals that end up with great maternal traits and great carcass traits. That would be something that you might potentially be doing with this type of program. Next system we'll take a look at is inbreeding. So with this, you have mating of related individuals, sires and dams which share at least one ancestor. This is typically found in the purebred industry. And with this, you're going to find that they have what they call an inbreeding coefficient, which is a measure of how inbred an animal is. And what this relates to in the genetic side of it is the probability that two genes of a pair in an individual will be homozygous because they're replicates of a single ancestral gene. That coefficient will range from 0 to 1, 0 meaning no chance, and 1 meaning absolute certainty. So, for an example on this, if you take a full brother and a full sister and breed them, you'll have a 0.25 coefficient, or 25% inbred. If you take a half brother and a half sister and breed them, you'll have a 0.125 coefficient, or 12.5% inbred. The results from inbreeding, what you're hoping to see is increased uniformity of the offspring of an inbred parent and result in the surface. The one problem you do have is the result is a surfacing of bad genes. Basically what this is, it's genes that can cause undesirable effects on an individual's viability, productivity, and or economic value. Problem with inbreeding is you may have two individuals that if you're breeding normally, each of them may have a recessive gene that wouldn't show up, but as you continue to inbreed, your odds of this gene showing up increase, and it could be a undesirable type trait. You see this a lot in the horse industry, where you have 5 diseases out there that they test for right now, and this is from inbreeding. It's where recessive traits have finally been bred down to the point where it shows up, and it's none of the diseases are particularly nice to the particular animal, so it's a potential side effect of this type of a program. So some of the results you may see from inbreeding that can be bad or a reduction in performance, because what used to be hidden recessive genes, like I was talking about, are now being expressed. To kind of combat this, they've kind of done a offtake of inbreeding, which they call line breeding. And this is an attempt to maintain a close relationship to a highly regarded ancestor. Typically seen more in the horse industry, but there are other industries out there where this does come into play. And again, typically it's going to be in your purebred industry, because that's where the breeding is typically more controlled and they know who the sires and dams are. So typical example of this is you'll have an elite sire that'll be bred to half-sisters, or you'll have a son of an elite sire crossed with a daughter of those said half-sisters. So with all of this now, you have your systems of mating. When you're setting up your systems of mating, is going to be determined by the type of facilities you have, your breeding schedule, method of heat detection, type of genetic program that you are running, and your market type. So one of the examples for this is if you're a seed stock producer, you would not want to use a straight crossbreeding system. Alright, so one of the mating systems we have here is hand mating. This is, you take your purebred breeders and you'll basically breed them in hand. This is to control the mating, so you know exactly when they're bred and who they're bred to. Females are typically kept apart from the males until the desired time of breeding. Advantage of this, prevents overuse of a particular sire, and you have certainty of mating and to which sire. Can increase conception rate by 5 to 10%. Some of the disadvantages with this type of mating system, it involves increased labor. Estrus detection becomes a 7-day-a-week job during breeding season. Next we have pin mating. Typically in this type of a system, the males and females coexist throughout the breeding season, and they may coexist year-round depending upon what the breeder and how their setup is works for them. This is typically used mostly by commercial breeders. Advantages to this type of a mating system is minimum labor. Heat detection is a responsibility of the sire. Disadvantages of this type of system is you have uncertainty of mating and the date of conception. You have uncertainty of infertile sires and of unbred females. And in this type of system, it may overwork the sire. So the next type of system we have is stud mating. This is typically used by the poultry and rabbit industry. Females are mated individually by a superior male, which is kept by himself in a pen or coop. The advantages of this type of a system is maximum breeding by a superior male. Disadvantages is it's labor intensive.